Good morning, good afternoon, good evening, ladies and gentlemen. And in today's video, we're going to be taking a look at transformations part 3. Now we're going to be putting them all together. And in today's video, we're going to be taking a look at it in general. Doesn't matter whether you're using quadratic or rationals or anything. So, just a quick reminder. Basically, if there's A, this represents our stretching and compressions. For K, this represents our horizontal stretch and compressions. And to see how, please refer back to the other two videos. For P, this represents our horizontal translations, left or right. And Q represents our vertical translations, up and down. Please refer to those respective videos to understand how. Okay. All right, so let's take a look. Now, in terms of points, you can actually, using transformations, any single point can be represented like this. So let's say this is your original point, xy. I can turn it into x over k plus p ay plus q. Okay. This is how you use your transformations to change your overall points. Now, something else that's very special, and this is when we talked about asymptotes earlier in another video, you can also use your transformations to find your asymptotes. So my vertical asymptote my vertical asymptote is done with my C. So basically, x is equal to C becomes my vertical asymptote. So in essence, x is equal to C over K plus P. And my horizontal asymptote can be found using my p-value. Sometimes you might name it D in another example, but so y, actually this should be a y over here. A little bit of mistakes at night here. Alright, so this should be a y, because why not? So y should be AP plus Q. That's all the stuff that affects it. So let's see what this looks like when we look at actual examples. Okay, so let's take a look at this example here. So here I give you 3 different functions with various transformations. Now, the first thing you want to do whenever you're working on these questions is identify what your parent function is. So here I see a squared, I see an x, so I know my daddy should be x squared. Here I see a fraction, so I know the daddy should be 1 over x. And over here I see a root, so I know that my daddy should be root x. Knowing this makes all the difference, because from there I can now label the things that are different. So I should label my transformation. So if I see a negative, well, that's 1, that's 2, that's 3, that's 4, and that's 5. I should have 5 transformations when all is said and done. So 1, I see the negative outside, which means this is a reflection on the x-axis. If it's on the inside, it's on the y-axis. 2, I see a 3, that's a whole number, it's on the outside, so this is a vertical stretch by 3. 3. I see a 5, that's a whole number, it's on the inside, so therefore this is a horizontal compression by 1 over 5. I see here a 3, and it's a positive 3, so I know this is a horizontal translation to the left by 3. And finally, I see a negative 5 on the outside, so this is a vertical translation down by 5. Okay, let's take a look at the second one. Once again, you want to label your transformations. So you've got 1, you've got 2, and you've got 3. Now, when you see the 3 on the bottom there, don't confuse that with your a value, because it's affecting the x on the bottom. So that's your k value, actually. So k is actually equal to 3. But I can actually factor this equation and make it look like 1 over 3 times 1 over x minus 2, which means if k is 3, my a value is 1 over 3. So really, I have a vertical compression by 1/3. 2, I've got a negative 2 on the inside, so because it's negative, I know this is going to be a horizontal translation right by 2. And then finally, a vertical translation up by 5. All right, let's take a look at my last one here. So in my last one here, again, you want to label. Before you label, though, you want to see if I can factor. And I actually can factor here because, well, 6 is in both. So, with that in mind, I'm going to label these 1, 2, 3, 4. So 1, positive 5 on the outside. This is a vertical stretch by 5. The 6 is on the inside, and it's a whole number. So that is a horizontal compression by 1 over 6. And number 3, it's a negative 1 on the inside, so this is a horizontal translation to the right by 1. Finally, you have a plus 3, so this is a vertical translation up by 3. Okay? Now, there is another way I can ask you this, and that is I can give you the transformations, I can give you the parent function, and you have to tell me what the new function looks like. So let's take a look at what that kind of question looks like. All right, so let's take a look at this example. So it's saying the graph of square root x is stretched vertically by a factor of 3, translated 5 units to the right, and translated 2 units downwards. Write the equation of the transformed function and graph it below. All right, so let's take a look. So f of x is equal to, well, I know it's a root x. What am I doing with it? Well, I'm stretching it vertically, which means there should be a 3 on the outside. Okay, is there any kind of reflections? No. So continue writing it. Square root. It is translated 5 units to the right and 2 units down. So if I continue writing, x and 5 units to the right, which means this should be negative 5. And 2 units downwards, so minus 2 on the outside. And that's what my transformed function would look like. All right? Now, to be able to graph it, you need to be able to understand how the original looks like. And to do that, I'd recommend writing a xy table. So I'm going to do an xy table for square root x. All right, so for square root x, let's use the standard, numbers, but at the same time I know that my x can't be negative, so let's use positive numbers here. So 1, 2, 3, 4. Actually, let's go with square numbers here. So let's go with 1, 4, 9, 16. All right. So that gives me square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and square root of 16 is 4. So let's put these in. So 1, 1, 4, 2, 9, 3, and we don't have room for 16 here, so we're just going to do it like this. And as I showed you guys in the parent function video, this is how the original one should look like. Now I know that it's vertically stretched by 3, and it goes to the right by 5, and it goes down by 2. So let's see what this new table would look like. Okay. Now remember, when you're making your new table, this is why we showed you earlier what the new one would look like. Remember, you have to use the new point formula. So remember, this should be, instead of x, it should be x over k. There is no k in this case, so you're good there, plus p. So this should be x plus whatever my p value is. My p value in this case is 5. And as for my y should be ay plus q. So it should be 3y plus q, which is minus 2. Okay, so you take your originals and you plug them in. So you have 1 plus 5, which is 6, 4 plus 5, which is 9, 9 plus 5, which is 14, and 16 plus 5, which is 21. These are my new x values. My new y values, 3 times 1 is 3 minus 2 is 1. 3 times 2, which is 6 minus 2 is 4. 3 times 3 is 9 minus 2 is 7. And 3 times 4, which is 12, minus 2 is 10. And these are my new x and y values. So let's see what these look like. Now it's going to be hard to put some of these x's here, mainly because I have a 10 radical area here, so we're going to have to make do here. So I'm just going to put the 6 and 9. So the 6, that should give me 1. The 9, that's going to give me 4. Okay. The 14 would have given me 7, and so on. So moving it down. And that's what your new one looks like. And as you can see, it's moved to the right by 5 and moved down initially from what it was by 2 for each of the points. And that's actually how the stretching is affected as well. And that's how you graph and show your transformations from a graph. I hope you have understood everything that we've done, and have yourself a fantastic day.